So here we are, 3.3 angle relationships. We're going to talk now about angles inside triangles and other polygons, both inside and outside, interior and exterior angles. So let's just go over a few basic concepts about triangles that we already know and just need to review. So we have different kinds of triangles. So we have scalene triangles. There are no equal sides and no equal angles inside a scalene triangle. Isosceles triangles have two equal sides and two equal angles. Equilateral triangles have all three sides equal and all three equal angles inside. Okay, and just to review some angles, acute triangles here, these are triangles that have three acute angles, which are angles less than 90 degrees. So these are smaller than the L shape. A right triangle is one triangle with a right angle in it. Okay. And an obtuse triangle has an angle inside that is an angle between 90 and 180 degrees. So down here, here's an angle that's bigger than 90 degrees. Okay. All right, so interior and exterior angles of a triangle. So you need to recall a fact from our last lesson. So let's recall here. And I'm going to just draw a triangle. And I'm going to label the measures of each triangle inside as A, B, and C. And we just need to remember that the interior angle rule, so A plus B plus C is equal to 180 degrees. Okay. So formal definitions of interior and exterior angles. So interior angles, these are the angles formed on the inside of a polygon by two sides meeting at a vertex or a corner. Okay. And an exterior angle is an angle formed on the outside of a geometric shape by extending one of the sides past a vertex. So you notice there's a vertex here. If I extend it here, I get an exterior angle. If I extend this line here past the vertex, this angle on the outside is an exterior angle. The same thing up here, I can find another exterior angle. Okay. Now, the thing here is there's a special property of these triangles, as well as of triangles, that the exterior angle at each vertex of a triangle is equal to the sum of the interior angles at the other two vertices. Okay, so what does that mean? Well, it means if I have a triangle, let's draw one right here. So here's a triangle. I'm going to extend one side past its vertex. And this triangle here, I'm going to label it. Let's label this part. Let's zoom in a little bit here. So let's say this side here is A. This over here is B. And what this rule says is that the exterior angle, so here's an interior angle, but this exterior angle is going to be equal to the interior angles on the other side. A plus B is going to equal to the exterior angle over here, A plus B. Okay. So how do we know that's true? There's a little mathematical proof for this. So let's write this down, mathematical proof for this. And that is, well, so we know based on supplementary rules that the angle over here, interior angle rules, the inside, this angle here plus this angle here plus this angle here, these three have to add up to 180 degrees. So I already know this angle here. This is going to be 180 degrees minus the sum of these two angles, A plus B. So minus A plus B. So if I do that math, I will know what's the inside angle here. Okay. So that's what's the angle A plus B over here. Well, if I use supplementary angles, meaning the angle inside here plus the exterior angle here have to add up to 180 degrees. So if I took 180 degrees and I subtract the angle on the inside, and we know the angle on the inside is what we have written here, so 180 minus A plus B. Okay, and then I do a little simplification. So if I, on my next line, I will have 180. So that this 180 here comes down. Don't forget there's a minus sign in the front, so that's going to change the signs inside. Imagine I'm distributing a -1. So I'm going to have minus 180. Negative times negative is positive, A plus B. Okay. So right away, you can see that this 180, take away 180, they cancel each other out, and I'm left with A plus B, as I already said in the rule. So the rule is A plus B is the exterior angle. There's my little proof there. Okay. So using that newfound knowledge, you can already look at some examples that we have over here. So how do I find the exterior angle y? Well, it's just going to be the sum of the two interior angles on the other side. So here y is equal to 94 plus 55, which is equal to 149 degrees. Over here on the, let's go on the right side. So how do I find x? Well, if it is a isosceles triangle, two equal sides and two equal angles, so 70 degrees is down here, 70 degrees would then be over here. So using the 180 degree supplementary rule, then x is going to be 180 degrees minus the interior angle 70 degrees, which is just 110 degrees. Okay. Next one down here, a little bit more tricky. We got to find several things. So let's look at B first. We can identify. So B right away we can say is 50 degrees because these tick marks over here indicate that this triangle that you see here on the left, this is an isosceles triangle, two equal sides, so and two equal angles. So 50 and B have to be the same. Okay, and once we find B, then we can find A using the interior angle rule, because all three angles inside of a triangle have to add up to 180. So I could say here A is equal to 180 minus 50 minus 50, and that is 80 degrees. Okay, next we can find D. Okay, this is the supplementary angle rule, so B and D have to add up to 180. So I can say here D is equal to 180 minus whatever angle B is, which is 50. So 180 minus 50, which is 130 degrees. And then finally, we can find angle E. 180. Sorry, I made a tiny bit of a. Let's have a quick look here. So angle E. So I need angle C as well. Okay. So angle E. Angle E and angle C are the same. Okay, so if I find angle E, I'll know angle C. And the reason why is because these tick marks over here indicate that we have another isosceles triangle. Okay, so this side and this side are the same. So the C and E must be the same angle. Okay, so if I find E, and E is going to be, remember C, D, and E have to add up to 180 degrees. So I would have to say here, let's write this. So C plus E plus D equals 180 degrees. But we know C and E are the same. So if I could just say 2 times E plus D is equal to 180. And we already know D is 130 degrees. So 2E plus 130 equals 180. Now just solve for angle E. Okay. So if I subtract 130 from both sides, I will get here 2E equals 50. And if I divide both sides by 2, so E will equal 50 over 2, which is 25 degrees. So angle E and angle C are both 25 degrees. Okay, so what if we go beyond triangles? So what I would like to do is try and copy and complete this table. I'm going to go through the first couple of them with you. So I'm going to say here, here's my sketch of a triangle. How many sides does this triangle have? Well, we have 3 sides. How many diagonals from one vertex? Well, we have no diagonals. I can't draw a diagonal from this vertex to any other vertexes. That will already be the side here, and that will be already this side. So there are no diagonals. Okay. Number of triangles that we see here, we just see one triangle. Sum of the interior angles, we already know that the sum of the interior angles is 180 degrees. And the sum of the exterior angles is 360 degrees. Okay. Now, where did I get this where does this come from? Where does this 360 degrees come from? It's very simple. I'm going to find a little blank space here. So if I look at a, let's take a different look here. So let's, well, I'll come back to this in a separate video. So just believe me for now, 360 degrees is for any polygon, any what we call a convex polygon, the sum of the exterior angles is 360 degrees. Okay. All right, so let's do a quadrilateral next. So I'm going to draw a four-sided shape, something like this. Okay, there you go. So we have four sides here. And I'm going to now draw a diagonal from one vertex. So let's say if I pick this vertex over here, I'm going to draw a diagonal. How many diagonals can I draw? Well, I can only draw one here. Okay, so it's the only diagonal I can create. So I have one diagonal. How many triangles do I now see in my picture? Well, I have one here and one here, so that's two triangles. And now the sum of all the interior angles. So if one triangle has a sum of interior angles of 180, and I have two triangles, well then the total sum will be 180 times 2, which is 360 degrees. Okay, and again, the sum of all exterior angles is going to be 360 degrees. Pentagon. So here's a pentagon, five-sided shape. Draw a pick a corner, pick a vertex, and just start drawing diagonals. I can draw one over here, and I can draw one over here. And what you will see is that I have three triangles inside this one. Okay, all three triangles don't have to be the same shape, but as long as you see three. So here you have a five-sided shape, two diagonals, three triangles. The sum of the interior angles is going to be 180 times 3, which is 540 degrees. The sum of the exterior angles is 360 degrees. Now what I'd like you to do is pause the video, and I would like you to complete the rest of this table. And see if you can notice a pattern. Okay, so hopefully we had a chance to go through the rest of the table. I'm going to quickly go through the answers here. So here's my hexagon. And here's a series of diagonals. Okay, so six-sided shape. This is the number of diagonals, so I have 3 diagonals, 4 triangles, total sum of 720 degrees for my interior angles and 360 degrees for my exterior angles. Heptagon has 7 sides, 4 diagonals, 5 triangles, 900 degrees interior and 360 for my exterior. My octagon has 8, and again, same idea, keep on going, 1080 and 360. And you might notice a little bit of a pattern here. Okay, so for any n polygon or n-gon, we have n sides. You're going to have 3 less. If you notice the number of diagonals, it's 3 less than the number of sides. 4 minus 3 is 1, 5 minus 3 is 2, 6 minus 3 is 3, 7 minus 3 is 4, etc., etc. So the number of sides or number of diagonals is going to be whatever the number of sides is, n minus 3. Okay. And then you might notice the same pattern for the number of triangles. So if I have 3 sides, I have 1 triangle. 4 sides, I have 2 triangles. I'm subtracting 2. 5 minus 2 is 3. 6 minus 2 is 4. 7 minus 2 is 5. So I have n minus 2 triangles. Okay. And then you might notice that whatever number I had in this column, I multiplied by 180 to get the number of the sum of my interior angles. So 180 times 2. 3 times 180, 4 times 180, 5 times 180, 6 times 180. Okay, so similarly, I'm going to take whatever I have here, n minus 2, and multiply that by 180. So the sum of all the interior angles of any n-sided shape is 180 times n minus 2. My exterior angles is always going to be 360 degrees. And again, in a separate video, I'm going to show you why this is. Okay, all right, so now we know that. Classifying polygons. So again, the polygon is a closed figure formed by 3 or more line segments, and the regular polygon has all sides equal and all angles equal. So that's a regular polygon. If it's not regular, then you can have different side lengths and different angles in that polygon. Right. So some quadrilaterals may have special names. A regular quadrilateral is a square. An irregular quadrilateral may be a rectangle, a rhombus, parallelogram, or trapezoid. So here's some examples of different quadrilaterals. Different, all of them have 4 sides each, but they may have different lengths, different angles. Okay, so the key idea that you need to take away from this is that the sum of the exterior angles is 360 degrees for a convex polygon, and even more importantly, the sum of the interior angles is always going to be given by this formula, 180 times n minus 2, where n is the number of sides. Okay, now a convex polygon. This is what a convex polygon looks like. You have all of these sides forming something that's convex. A concave polygon would be like something like, you take the wall of your convex polygon, like this one here, but instead you dent it. You dent it inside. Okay, so you kind of have this big dent, like you punched the wall and made it go inside. Whereas everything else on the convex is all outside. Okay, so a convex polygon, all the interior angles of these polygons are less than 180 degrees. However, a convex polygon, the one that you dent, would have an interior angle that's much bigger. Okay, so here's an interior angle that's bigger than 180 degrees. And in that case, these formulas wouldn't necessarily apply. Like this convex wouldn't say all the exterior angles of a convex polygon is 360 degrees. That won't work. Okay, so let's just do some examples. So how do I use some of these formulas here to help us solve some problems? Determine the sum of the interior angles of a 12-sided polygon. So the sum of all the interior angles is just S equals 180 times n minus 2, where n is equal to 12. Okay, and then I just plug that in there. So S equals 180 times 12 minus 2. And so S is equal to 180 times 10, which is 1800 degrees. So all the interior angles of this 12-sided shape add up to 1800 degrees. All right, so what about so let's see. Calculate the measure of each interior and exterior angle in a regular polygon. Okay, so let's look at this polygon here. How many sides do you see? I see 1, 2, 3, 4, 5, 6, 7. So this polygon has 7 sides, and I need to find what is the value of each angle inside. So all the angles are equal because it's a regular polygon, all the same sides, all equal angles. So for a polygon of 7 sides, the sum of all interior angles is 180 times 7 minus 2, which is 180 times 5 if you follow BEDMAS rules. And then 180 times 5 is 900 degrees. So I have to take this 900 degrees and divide it by 7 equal angles. And if I do that, I get 128.57 degrees. Okay. And because this is a convex polygon, then the sum of all the exterior angles is 360 degrees. So if I have 7 sides, 360 divided by 7 is 51.43 degrees. Okay, and by the supplementary rule, so if I know that the interior angle is 128.57, and I know the exterior angle has to be 51.43, you can just do a quick check because this is the supplementary angle rule. Both of these angles should add up to 180 degrees. So I'm going to just circle these two and I say here, these should add or sum to 180 degrees. Okay, so here's another polygon, a regular polygon, 10 sides this time. Okay, so for a polygon with 10 sides, the sum of the interior angles is 180 times 10 minus 2, which is 180 times 8, which is equal to 1440 degrees. Okay, so the interior angle is 1440 divided by 10, which is 144 degrees. Okay, and the exterior angle is 360 divided by 10, 36 degrees. And if you see 144 plus 36, that does add up to 180. So the math works out. Okay, number 3. How many sides does a regular polygon have if each interior angle is 140 degrees? So there's a couple of ways you can do this one. Let's call this one method A. So I can take the sum of the interior angles, S, equals 180 times n minus 2. And I know that if each interior angle is 140 degrees, then the 140 degrees times the number of sides that I have will give me the total sum, right? So 140n. And that's going to equal, on my right side, 180 times n minus 2. And all I have to do now is solve for n. Okay, so here I'm going to have 140n equals 180n minus 360 when I expand the right side. And if I subtract 180 from both sides, I'm going to have negative 40n equals negative 360. And if I solve for n is going to equal 9. Divide both sides by negative 40. So this is going to be a 9-sided polygon. Okay. Second method. There's a second method to do this. So method B. So if I know my interior, so if interior angles is equal to 140 degrees, by the supplementary angle rule, the exterior has to be 180 degrees minus 140 degrees, which is 40 degrees. Okay. So if the exterior angle is 40 degrees, and I know the total for any polygon, the total exterior is 360 degrees. And I can find the number of sides by saying, well, 40 degrees times the number of sides n has to equal 360 degrees. So what does n have to be? Well, if I divide both sides by 40, I'll get my answer. And we already know the answer, n is equal to 9. 360 divided by 40 is equal to 9. All right, let's find the value of some missing angles here. So how do I find the value for angle C? The sum of all the interior angles inside a quadrilateral here. It's a 4-sided shape, so it's going to be so S is equal to 180 times n minus 2, so n is equal to 4, so 180 times 4 minus 2, which is 4 minus 2, which is 2. 2 times 180 is 360 degrees. So to find C, then C will be, so the whole thing is 360 degrees, so 360 degrees minus each interior angle, so minus 130, minus 100, and minus 60. That's going to equal 70 degrees. Okay, so now you see a polygon here with a bunch of exterior angles. So I can use the supplementary rule to help me find these angles. So if my 112 is my exterior angle, A is going to be 180 minus 112. So A is equal to 180 minus 112, which is 68 degrees. Same thing for D over here. So D is equal to 180 minus 85, supplementary angle. So this is going to be 95 degrees. Okay, so to find C, so if I know the inside here is 68, the sum of all the angles inside a quadrilateral here is going to be 360. So C is going to be 360 minus 68 minus 85 minus 94. Okay, don't subtract the 95. This is exterior. I want to only subtract the interior angles because the interior angles add up to 360. So angle C over here is going to be 113 degrees, which leaves B, and B using the supplementary angle rule is 180 minus my answer for C, which is 113, and that is 67 degrees. Finally, at the bottom, complicated one, have to use some algebra here. So what I indicate here is that the interior angle is 3x minus 18, exterior is x. So first of all, these two here, they have to add up to 180 degrees. So x plus 3x minus 18 equals 180 degrees. Okay, collect like terms. 3x plus x is 4x, minus 18 equals 180 degrees. Add 18 to both sides, so I have here 4x equals 198, and I divide both sides by 4. X is equal to 49.5. Okay, and so if x is 49.5, it's simply a matter of plugging in the x here to find the angles. So I have here 100. So this one here, okay. So if the inside angle here is 130.5, here I have 49.5. What about y? Well, I already know that x is 49.5, so 2 times 49.5 minus 12 is equal to 87. Okay, so that means y is going to be 180 minus 87 using the supplementary angle rule, and so that makes y 93 degrees. Okay, up here x plus 20, that makes 69.5, which means z, if I subtract that from 180, would be 110.5. Okay, and then if you do the sum of the interior angles of a quadrilateral, 2x minus 12 comes up to 87 degrees. So 130 plus 87 plus 69.5 add up to plus w add up to 360. So that leaves if you solve for w, that makes w 73 degrees, and supplementary angle rule makes this one 107 degrees. Okay, and I encourage you to work all this out algebraically. Okay, instead of waiting for me to write it all down, I want you to see for yourself. So these are the answers I want you to try out solving for x, y, w, u, and z. Okay, and that ends this lesson for today.